Hello everyone, how is everyone doing? Today we are going to talk about Java 19. So as we all know that Java is one of the most popular languages which is being used for software development. You can see around you in various companies wherever you work or in college that it is quite popular. And not just being a Java developer, but being a software engineer, it is important to understand where a particular language is heading so that when you get mature enough or senior enough and you get an opportunity to choose what language or what framework or what platform you need to use for a project, so you make the right choice based on the use case and you map it correctly. So in this video, I'll talk about the latest feature of Java 19, which was released a couple of days back. So to give you a little bit of context that Java 19 was, or JDK 19, was released in September 2022, that is a couple of days back. And one important thing which you would have noticed is that now Java has been getting released every 6 months. So this is the story which has started after Java 9, that they have decided to release the language every 6 months. The If you see that Java 19 was released in September 2017, and then if you see the pattern that every 6 months there has been a new version. So it gives up the market know about what are the latest things which are happening for the language, and it also keeps up the buzz and gives a bigger or a shorter feedback loop for the community or the Java to know what people want and what is working and not working. So I would say quite an intelligent decision to release every 6 months. So this Java 19, if we talk about it, so this version is actually a preview version. This is not a long-term support, but definitely worth understanding where the language is going. So if you see, there are three verticals on which the new feature of Java is released. So the first is concurrency, the second is language preview feature, and the third is library preview. I'm not big fan of library preview. The way the features which are being mentioned here, I didn't find it that exciting. However, I found the concurrency feature and the language preview feature very interesting. It makes the Java code less verbose. It makes us developer more empowered in terms of being able to debug the code, and it also makes the system more performant. So the concurrency feature around the virtual threads, which is nothing but an optimized or lightweight thread, which is there in JDK 19. The structure concurrency, which will help you debug the code faster, especially in the multi-threaded environment. We all know as a developer what a nightmare it is to debug a multi-threaded code. And then there are record patterns and pattern matching for switch statements. So even this is quite interesting in the sense that in a lot of places you end up making mistake, and there can be a coding mistake in your program. So this feature would actually make your code less verbose and would make sure that a lot of validations are done at the compile time. So let's start these features one by one. So we'll start with the first feature of virtual threads and see how virtual threads are introduced and helpful in Java 19. So the first thing first about the virtual thread is that it's a preview feature, which means that it is not enabled by default. So whenever you run a program, you need to enable it by minus minus enable preview parameter in your Java C and Java command. And then the other important thing is that what is virtual thread? So we all know what thread is. By thread, you mean you can spawn various threads and you can get the task done. So virtual thread are the lightweight threads. So that's a plain simple definition. And by lightweight thread it means that you can create as many threads as you want, as many virtual threads as you want, and they will take care of the concurrency, they will take care of the scheduling, or they will take care of getting the callback, that is the future objects which you use. So as a Java developer, you don't need to think in terms of multi-threading, you can think in terms of synchronous programming, and you can get the job done. So if you see the current Java implementation, just to give you some idea, or you already know about it, is that JDK implements thread as a wrapper around the operating system threads. So this means that whenever you are running a program, you would know that if your machine or the production machine or your machine is 8 core machine, so somehow your concurrency will be limited with 8. After 8 you would start to see some deterioration. In fact, not 8, there would be 1 or 2 cores being occupied by other services. So the number of cores your uh, machine has, so you cannot get concurrency more than that. So there are ways to get around that, and we all know that that is using the computable future, or the reference to some thread, so that you our operations are not blocked. So which means that whenever you run a code, you can wait for the dependent services, and the running code will not be blocked. So to explain it in terms of diagram, so this diagram is also quite clear that you have a public static void main, that is the main thread, and this main thread is calling the other thread T2, and likewise you see a tree-based structure, and these all calls are asynchronous. So the call from T1 to T2 goes as asynchronous, and T1 gets a reference to a future object, so that T1 is not blocked, and then T2 makes a call to T4 and gets a future reference of T4, so that the particular the CPU cores can get free and use it for some other threads. So these are all non-blocking programming which we all have been doing in Java, that is using future and using completable futures. And this is quite common in terms of people calling other threads, for example here, and these other threads can also be the dependent services. So whenever you make some API call, you make await, async await in C sharp, and completable future in Java. So we are talking about Java, but most of the programming languages have this notion. Or you make call to the database. So you don't block the thread, you make it free for some other thread to come and take the CPU core or the processing power of the machine. But what's the problem in this? So the first problem is that the stack traces. So we all have had faced this nightmare in the production system where the stack trace does not say anything. There is thread 1 which is called thread 2, and thread 2 has called thread T. And if those calls are asynchronous, then you would not get the call stack, the proper call stack. So it will always get very hard to understand who called whom. Even the profilers, whatever profiler you use, even they cannot show those call stacks. So this is a big problem, that you want to see which code path is taking maximum memory, and then again the mapping of the caller to callee gets hard. And this is again a very common problem statement, that whenever you are debugging on your IDE, whatever IDE like IntelliJ, Eclipse, or VS Code, you would end up in a problem where you do a step over or a step into, and then you don't reach the running code because it is running in some other stack, call stack. So you need to specifically put a debug point there, and then you need to run the debugger. So these things also don't work. And for all these problems, there is this lambda expression which was introduced long back, I think in Java 8 or 7. But you cannot write your whole program in lambda expressions, and all this also gets very hard to understand. For a small data pipeline or a small flow, it's fine to have a lambda expressions, but writing a whole code base is also not very desirable. So you see a lot of problems around the current system, and this problem is common. So what we do when the problem is common, we get a solution from the platform and not let all the developers do the same job again and again and again. So let's talk about the virtual thread. So this virtual thread is something which has solved all the problems which we have talked about. So the first thing is that virtual thread is still the instance of java.lang.thread, but we would not be using java.lang.thread. We'll be using the wrapper on top of it. And this is being developed by Java, so we can directly use it. And this is not tied to a particular OS thread. So what will happen is that they will be available in plenty. Create as many virtual thread as you want and let Java handle it. And you can have a high concurrency also, because these will be the lightweight thread, and Java will handle the multi-threading and those future references and all those things, and you just need to think in terms of single threaded application. That's what we do. We think single threaded. I called this service gave me the result. We don't think in terms of, hey, I called this service in some other stack call stack, and then that call stack waited for the callback, and then this callback gave me data. We don't think in those terms. So this is what will be corrected in this virtual thread. Now let's move on to the coding example. So I have already written the code for the same. Let me move on to the coding window. So this is the virtual thread example, and I will showcase you with the what happens in both the cases. So first of all, I created public static void main, and I created a method. So first of all, I'll run this code with current Java implementation. So let's see what happens. So I have a program, and how do we run? So I will have a Java C minus minus release 19. This is what I will need to do to enable the Java 19 feature. Otherwise it will give me error. So let's run this. And yes, it will give me the class file. And now I will run the Java minus minus enable preview virtual thread example. So the same thing with my Java current Java implementation. So you see it is running the code, but 1,000 threads being run using the cache thread pool. This is how it was being done earlier. So if you increase it to higher values, you might even end up getting error as well. So let's say I increase 1020. So the performance deteriorates a lot. So if I run the Java C again and run the Java enable preview, so you can see it is running a little slow, and sometimes it will even give you the out of memory exceptions as well. So right now I'm just getting lucky that I'm not getting any stack traces or exception out of memory exceptions, but you can definitely get it because there is no limit to the number of threads which are being created. So let me stop this, and let me move to the other one, which is the virtual thread pool executor. So this is the new thing which has been introduced in Java 19. So yeah, before that, let me show you that you can check the version of Java using this, and you see that I'm using JDK 19. You can download it from Open JDK website or Oracle website, wherever you want. There are quite a many flavors of Java now. So let us compile again, and we'll wait for the compiler. And you can see the warning that this has a preview feature of Java 19. And now let's run the Java program. So you can run, and it does run faster. It gets hard to show in the recording, but trust me, it is faster compared to the other one. So if you I'll you can check the performance analyzer or memory analyzer, and you will find that the virtual thread consuming lesser memory. So for the sake of this video, I have not covered it, but I have definitely checked it that how fast the virtual thread is compared to the 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 current Java implementation. So what you need to do is a simple, in the executor class they have introduced this new virtual thread per task is executor, and you can pass this here, and apart from this the method is same. Instead of thread or sleep, you can have a dependent task, and those dependent tasks can do your job. So this is what the virtual thread does. It's a lightweight thread. You can spawn using a new virtual thread per task executor. And I suggest you that you do the experiments. This video would get quite long if we get into the depth of each of the feature. So covering the breadth here. This one, I mean, you can go to the documentation which I have linked in the beginning, that and Java has already done the experimentation on this. So you run this program using the current executor service, where the threads are tied directly to your CPU processes, versus you run using this. You will see the performance gain. So this was all about the the thread, the virtual threads. There is more example which is worth covering. That is how this virtual thread makes you think in terms of single threaded application and not the multi-threaded application. So here you, in your block of code, you just have a executor.new virtual thread per task executor, and you can submit the request here, and then you can get the value. So here the stack traces and how the program works, you don't need to think how would the thread be spawned and how the value would, you will get the values back. All you need to do is use the virtual thread executor, and they will take care of the callbacks, they will take care of the performance and stuff. So this is the example which I took from the documentation. The previous one was I tweaked a little to showcase the use case in terms of the experimentation and demoing, but this is one more example which is there in the doc. So all in all, quite an interesting feature. Do try it and see how it works for you. So in this way, we have covered the first one, that is the virtual thread, and now we'll move on to the structured concurrency. So you will see that this is how I'll run all the programs using Java C and Java. This because I thought to use the IDEs, but even now it has not been much time there. These the language feature is still not there. So if you run on your IDs like IntelliJ or VS Code, you will see a lot of compilation errors and warnings. So I ditched that, and I use the plain simple command line systems. So now let's move on to the structured concurrency. So even this is one of the features for which I am very excited about in this release of Java, because this will again make the life of developer very easy. So this is an incubator feature, and this will, as we see, it will increase the maintainability, reliability, and observability of the multi-threaded code. So it will make the life of us as a programmer very easily, and it will promote the style of concurrent programming which can eliminate common risks arising from the cancellation and shutdown, such as thread leaks and cancellation delays. So a lot of things to talk about here, and I would want to showcase it with the help of example. So this example is also not exactly this, but a little different example is being talked about in the documentation as well. So this is a common scenario. Again, this is what you would do generally in your programming or in your system as well, that you have a thread T1 and it spawns two thread T2 and T3, and then it says that, hey, I have submitted two requests, and I would wait for the two responses and then return the data for both T2 and 3. this is a very common example. You make two DB calls, you make one DB call and one service call, and then you collate the data and you give it to somebody. So you all would have done in your day-to-day programming as well. Now the problem arises in case of failures. How do you handle the failures? So here, let's say this is the program, and let's say T3 fails. So what will happen? T3 will throw the exception. T1 will also throw the exception, because if you are not catching it, you will end up throwing it. Now this T2 will continue to execute. It will not even come to know that, hey, this has failed, this has failed. This will continue to execute unless you send them a message that, hey, cancel the process. So this is the problem number one, which is there in the current program. I understand this problem is solvable, but you have to solve as a developer. And this is a common problem. So whenever there is a common problem, we take it to the platform and not let the individual developers solve this problem. And yeah, the problem is solvable, and then it requires some skills to handle such scenarios and makes the code verbose. So this is the second scenario, the same thing, that is let's say T1, T2 and T3. So here what happens is that, let's say T2 fails. So this is the second one which got failed. So, and let's say T3 is a slow task, so T3 keeps on running. So here, since T3.get is written before T2, so what will happen, even though T2 has failed, you have submitted the task, even though in the callback you will get that this has failed, even then T3 will keep on waiting. So here the program, the value which you are getting later, the second one, this has failed. Still you are waiting for the first one, because this is a blocking call. Here you are waiting for the data. So even this is the problem, that if T2 fails, then there is a problem. If T3 fails, then also there is a problem, that in the other case they threw the exception, and these two threw the exception, and this kept on running, and here these two kept on waiting, and this has already failed. So this is also not very performant. You are just wasting the resource and wasting the computation power. So not very useful approach. And the third one, again, this is also the problem. I'm not saying that these problems are not solvable. Yes, they are solvable, but again, you would need programming skills to do that, and these things get a little trickier, and these things are not in terms of T1, T2, T3 in your projects, and they will be a bigger graph, and it will be a big jungle where you can't even figure out what is happening. So it gets complex. So here also, if T1 gets interrupted, so T2 and T3 will keep on running. They would not know that what has happened. So in all these cases, there are ways to handle it. That is, one is to have a future.cancel boolean method, which is already there in Java, and using this you can have a try finally block, and then you can send the cancel message to the threads, and those cancel objects will take care of when to cancel the data, and you need to honor those cancel messages as well. So definitely handleable scenario, and people have been handling it. And but yeah, it gets tricky for the larger code base. That's the point. And the other one is that the thread dump will not show a very promising data. It will be very confusing, because in the call stacks, it will get harder to map the caller and the callee, and then you have to apply your skills and the knowledge of the code, that what exactly is happening. So these are the net problems which I think you would be able to understand, that whenever there are multi-threaded programming, the life gets harder. And yes, if you get a chance, you definitely should use single threaded programming, and not unnecessarily add multi-threading, because when things get complex, they would get hard to debug. So the solution to all these problem is the structured concurrency, which Java has been trying to implement. The reason is that they want the language to be less verbose, and they want it to be more maintainable, readable, and debuggable as well, because they need to compete with the competing languages as well. So This is the new class which they have introduced, that is the structured scope, and they have introduced in JDK 19. And this class allows developer to structure a task as a family of concurrent subtasks. So instead of calling one method after the other, because there was no structure in the future, in the computable future classes, the caller can whoever has a reference can wait on the future object. There was no restriction as such, but here there is a concept of coordinating the threads as a unit. So now you can club the threads together and then you can wait for them. So this is a new thing which they have added. So I'll go on to the coding example, that is the structured concurrency.java, and I will compare the traditional Java implementation with the structural concurrency implementation. And yeah, I will run the code using Java C release 19. So this is how the code will look like. So I will quickly move on to my IDE. Just hold on. So this is my IDE, and let me go to the structured concurrency.java, which I have already written the code for. So first of all, I will run the existing Java implementation, and then I will go to the Java 19 implementation. So let me do this. And again, first of all, I'll explain the code. You all know public static void main, nothing special here. Nothing special here. This is the one which we are going to talk about. That is, existing Java implementation. So this is nothing, object being created of the current Java class. And then I created a thread pool where I will submit to tasks, and then I'll get the value. So here I am doing nothing special. I am calling a method. This is a dummy method. It can be any API call, anything. But for the sake of simplicity, I am using this method, and I'm using divide by number, so that whenever I want, I can get the exception to be thrown, so that I can show you the error. So here what will happen? Here it will happen that it's a loop of for loop of 100, and then throwing the exception. So it can happen that in fact, let me do one thing. I can have a where x equal to 1 by I, so I can fail fast as well. So I will call the method here. The first one will not fail, the second one will fail because of the divide by zero exception. But what will happen is that even though first has failed, the second will continue to execute because there is no cancellation message to the second one. And then this one will also fail. So this one will fail, but this one will continue to execute. So let's run the program here. So I will have a Java C minus minus release 19 minus minus enable preview, and then I need to add module JDK dot incubator dot concurrent, and this file name is structured concurrency.java. So again, this is an incubator module, that's why the warning, you can ignore the warning if you want to. And then let's run the Java minus minus enable preview minus minus add modules, again JDK dot incubator dot concurrent, and then structured concurrency. So let's see what happens. There are two function calls. One will get divide by zero error, and the other won't get that error. So let's see what gets printed here. Okay. See. So if you see the beginning of the program, the exception is you got the exception here, divide by 0 exception. You got the exception in the main method, but this method kept on getting executed. Ideally, this this method should have also failed. So if you're calling to two dependent services, in most of the cases, you would want that both of them should succeed. If one has failed, then the whole API should fail. I'm not saying that this is not the desired behavior, and that's why they, the new proposed solution also gives you those options. But here, it gets a little tricky, and that you need to pass the cancellation message. It gives you more freedom for sure, that whether you can choose to cancel or not to cancel, but most of the times you would want to cancel. So whatever you do most of the times should be handled by the platform, and that's what the platform has done. So coming to the other example, which is the Java 19 example, and what I'll do is I will comment out this one, and it's how it is. So you create an object because you need to call a local function, that's right. And here again, it's a num1 and 0, and this is the syntax for the how you are going to handle the program. So you have a try, scope is equal to structure shutdown on fail. There are two scopes. One is shutdown on fail, and the other is shutdown on success. So there are two scopes which they have introduced, and this is how you do. So in this one, it will take care of the scenarios that even in the case when one of these gets failed, the call stack will get failed. So we already have 1 and 0, we already have things in place, and what we can do is let's run the program. So we'll do a control C and Java C. It will compile again. It's a incubating module. Java keeps on reminding you, and when you run this, you see the failure occurs instantaneously. So it is very helpful. I would say that you can actually write the code and move forward in a simpler way, and this is why I like this feature a lot, that it helps a developer to not deal with cancel objects and cancellation tokens. These cancellation tokens are helpful, but they always get tricky, because now you need to deal with the cancellation tokens and you need to have more skills. But with this, you can have a family of objects, a family of threads, and those family of threads will deal the things. So in this way, we cover the concurrency and the structured concurrency sections. These are the sections which I have loved most compared to the other two. But yeah, this one as well, the second one, that is the language preview feature. This is also very interesting. This is interesting in the sense that this will make the Java program less verbose. So this is the common complaint from a lot of developers, that hey, Java is so verbose, you have to write so much of code to do such a small thing. So these are the problems which this record pattern is going to solve. So if you see this record pattern, it is a preview feature. So you can actually preview it, and just like a lot of other preview feature, this one also can be previewed. And this is the main USP, that is, it enhances the Java programming language with the record patterns to deconstruct the record values. So what are the record patterns and how it helps is something which we'll talk about. But just a small point which was introduced in the previous versions of Java is the record class. So when we talk about record patterns, we are talking about the record classes. That is, these are the classes which are transparent carrier of data. So if you recall, in the old days of Java, what you used to do, if you need to create a point class, you create a class, you create those variables, then you have a getters and setters and the two strings. Yes, I know that there are plugins like Lombok and all which help you a bit, but they truly do not help, because when you compile the program, the actual compilation, when you compile the program, the actually the compilation will have those classes. So it's just that you are not seeing that classes, but they get generated at the compile time with the help of those plugins. So this record class was introduced, which is an immutable class, and uh, just this one small declaration can help you to have a list of records or whatever. So quite helpful thing, and this is something which will be used in the record patterns. So this is how the old Java code looked like. So if you see, the old code was if O is instance of a string S, then use S. So in the Java 16, they changed it to this. So this is not a record pattern, but this is a pattern matching by type. So here you can write O is instant of string S, and then you can use S directly. So in just a small change given by the language, a lot of places, in a lot of places, you will end up saving one line of code. So this verbosity definitely helps. If you have lesser verbosity, then you will be less prone to error. So this was a problem already solved, and in the JDK 17 and 18, that is the previous version, they have extended this to switch case as well. So this problem has already been solved for Java 16 and 17 and 18. So what is being introduced in Java 19? Java 19 has introduced the pattern matching for record classes. So if you have already seen that the same thing was working for the string, that is O instance of string. Now Java 19 has introduced this. So you can even do this. So very helpful feature when it comes. It will definitely help people to have a lesser lines of code to do the same thing. And you can have something like this as well. So if O instance of point X and point Y, so not just the the variable P can be assigned, but here you can see the member variables can also be assigned directly. So if you see that it lifts the declaration of the local variables for extracted component into the pattern itself. So and initializes those variables by invoking the accessor method. So it does a lot of things for you. So instead of you writing that code, the platform is giving you the objects and making the language more declarative. So this feature is very interesting. Do try it. I'm not going to demo this one because this looks quite straightforward, and if you copy this code and run it, they would definitely run. So this concludes the record pattern as well. So now we'll move on to the pattern matching for switch statement, and this one will also help you to have a lesser verbosity in the Java application. So the verbosity is a very big problem in Java, and this one will also tackle this. So again, this is a preview feature. All the features in Java 19 are either preview or they are incubator, and that is why Java 19 is not a long-term support. In next 6 months you are going to see another Java version, but this gives opportunity for the Java team as well to have a better loop from the public, that what people want, and they get the immediate feedback in terms of bugs as well, so that these things can be fixed faster. So the preview Java is again a preview language feature, and it enhances the Java programming language with pattern matching for switch statement and statements. Uh, so the goals are that these are the four goals, and there are four examples for those four goals. So the first is that expand the expressiveness and applicability of the switch statement and statements by allowing the patterns to appear in the case level. So till now, whenever you have a switch case statement, you can only have the primitive data types or very limited use cases. But now it will have even the pattern matching as well. And then you have a null hostility, because earlier whenever you have a switch case statement and if you have a null, then you will get a null pointer exception, but not anymore. So this is also added. Then they have increased the safety of the switch statement by requiring that the pattern switch cover all possible input value. So many times it happens that you want to cover all the if else condition and you miss one condition. So this will be covered here. And yes, existing features do not break. So these are the requirements which are being held or solved here. So patterns in case label. So this is the first problem statement which has been solved, that if you have a these are the multiple classes, you can have a case here, and then you can have something like objects directly. So case triangle, whenever a triangle is there, then you can have a when statement as well. So case triangle, when t dot calculated area is greater than 100, you can have a large triangle, and otherwise you can follow other cases as well. So this is quite declarative. Instead of the nested if else, now you can have something like this. So in the traditional Java program, you would have if else. So these if else blocks, they get error prone. So instead of that, if you have something like this, so it becomes more declarative, easy to understand, visually appealing as well. So this is one of the features which is being added in the pattern for the case level. So the second is the switch covering for all possible scenarios. So earlier you would write the code in this way because there was not no matching by types, but now the matching by type is also there, case integer, case long. But here it is quite likely that you miss one of the scenarios. You miss, let's say you miss integer or you miss string, then you will just keep on returning some random value that is unknown. So you can tackle these things by writing the unit test and having the code coverage and stuff like those. But what if the language handles by themselves? So in the new code, if you do not have this default, then you will get a compile time error. So this is a very important thing. That is a compile time error, not the runtime error. So this is the beauty of the language, that as much as errors you can catch at the compile time, it will be good compared to you deploy the application on prod or wherever and then you get error. So if you do not have this statement, then you will get the error that, hey, you have not covered all the scenarios. So this is one important feature which has been added in covering all the scenarios. The third is the null handling. So null handling also gets quite interesting. This is how the older code looked like. You have null handling here, and then you have a switch case, because if you have null, if you pass null here, you will get null pointer exceptions. But now in the new Java 19, they have handled this scenario. You can have a switch case for null as well. So this will also be good for the developers once it gets live. But good to see that Java as a programming language is moving towards an approach where people would make less mistake. So if the language is being used so widely, then people can make mistake, and you can blame the developer to make such mistakes. But what if the language supports it? That would be the best thing to do. So this is one other thing which has been added, that is the null support. So this covers the pattern matching for switch as well. So these are the two features, that is the virtual threads and the structured concurrency, which needed the demo. You could clearly see why this is important, and this will be very interesting feature in the coming Java versions when it get released. These features, the other two are primarily making sure that developers don't make mistake, and they provide more power to the developer, and they make sure that the debuggability of the things are easy. So these are the two which are covered, and now we move on to the library review. These are mostly around the memory management. So we'll talk about these as well. However, when I read this about these, I am still not convinced where would I use them in the production? There are some scenarios which are being mentioned, but in general, as a software backend developer, you would prefer to use the alternates which are there. But definitely we can go through it. We can see in future how these two evolve. As of now, I'm still apprehensive about where these two APIs will lead to and why they are needed. So I'll cover and I'll share my perspective on these two APIs. But definitely you should read about it, and we'll see in the coming days how much. Yeah, we can talk about these APIs as much as we want, but we need to think: are these use cases applicable for most of the people or not? Is the question. So let's talk about these API one by one. We'll start with the foreign function and the memory API. So this is again preview API, and it introduces an API by which Java programs can interoperate with the code and data outside the Java runtime. So till now, this is the problem that Java, there are things like JNI using which you can interact with the code outside of the JVM, but they are creating this foreign function and memory API which will be, as they say, better than JNI, and there are problems in the JNI which they are going to solve. So the first is that introduce an API by which you can access code as well as data. So not just the code as well as the data. And with this API, you can call the foreign function and the foreign memory objects. So this is the facility which is there. So accessing the foreign memory. So the thing is that we all know that Java in itself has a JVM in which you can put the data, for example hash map, list, etc. And a lot of times this is how you deal with the data whenever you want to have a local variable which will be used across things. You have a constant class and you put it there, and if it is a bigger data, you put it in the Redis or some external store. That's how you deal with. However, if you have a bigger data, if you have data of, let's say, 1 GB, and you have kept in your JVM. So first of all, it will be approachable, or it can become a candidate for garbage collector. So let's say you have a use case in which you do not want it to be garbage collected. So in those cases, you might end up recomputing that data again and again and again. So accessing off heap data becomes important. That is something which you don't want it to be in JVM, so that garbage collector does not collect it. So they are needed for the libraries like TensorFlow, and these all APIs or libraries are mostly around the heavy data. So in those cases, you don't want the cost of loading the data again and again, and you don't want the garbage collector. So there were some alternatives, but those alternatives have the limitations. For example, byte buffer is one such thing in Java, but they have the limit of 2 GB. So you cannot load data bigger than 2 GB. Then there is sun.misc.unsafe. This package is there, but they themselves say that they are unsafe. And then they are highly discouraged as well. There are documentations which say that, hey, don't use this one, and they can be unsafe as well. You can read about why they are unsafe. I'll not cover it for the sake of the length of this video. And this is JNI. So for the JNI, there are performance impacts as well, and for the larger application where the performance is the criteria, this would not be the best choice. So all in all, whatever alternatives there are there, they do not solve all the problems. So hence they came up with a new solution, that is the foreign memory. So they have, and likewise you can have a foreign functions as well. So Java has JNI, but what other languages provide, JNI cannot provide. So for example, Rust and C and C type package in Python. So Python has a C type package in which loading the program of other language is very easy. In Java, there is JNI, but it is not as dynamic or as good as what C types has. So this is what is being solved in the foreign function in the memory API. This is what being talked about in the documentation as well. They have a demo of how to load a Redux sort program of a C program into your code, but I would say that it still needs to be mature. So if you see the documentation of this particular feature, they would be able to load the C code of sorting in Java. So essentially, what they do is they have a Java program, and they load a C program, and then they sort data. So this is what they do. But my problem is that there are other solutions as well. For example, there is a protobuf solution in which the various languages can interact with each other. And yeah, I still think that this particular feature needs a better pitch for the developers to use it. So yes, you can do that. You can load the C program in Java and then run it, but the program was still quite verbose. It was not a one line code to load a C program. You had to write around 5 to 6 lines of code, and in fact more a lot, and each of the line of code you had to understand properly before writing and deploying in the production. So I would say still not very appealing for the programmers to use them. Just use the library in the particular language, or there are other methods using which the current solution whichever are there, and you can live your life happily. So this is how the uh, the foreign functions and the memory API is being covered. And now we'll talk about the last one, that is the vector API. So vector API is again the fourth incubator API. So this one was released all in Java 16, 17, and 18, and now it is the fourth version of this API is released in Java 19. So the main advantage of these incubator APIs and the preview API is that the Java as a company or as a organization can make frequent changes before they reach the general availability. So likewise, they have improved a lot since Java 16, 17, and 18. So the first is that they have enhanced the API to load and store the vectors to and from the memory segment. So there are two types of data: scalar data like integer, in float, double, etc. And then there are vector data, that is the array, for example, that is the contiguous storage of data. So you can load and store from the memory segments, and they have added bunch of features like compress and inverse, and there are bunch of features which they have talked about in the documentation. You can go out and look into this one would be I'll just touch upon the surface about what exactly it can do. So vector API comprises of the fixed sequence of the scalar values as I talked about, and you can do binary operations between the two vectors. So let me move here. So for example, there are two array, and you want to add the corresponding numbers of the two arrays. So you can do the operations in the vector APIs quite easily as they say so. But yeah, I have seen that the code being a little complex compared to what you have in a regular programming model as well. So you can have, if you have a two vectors each covering a sequence of 8 integers, and you want to be added together with a single hardware instruction. So this is the important point. They say that you can do that in a single hardware instruction compared to you would need to do in a for loop to do the same operation. So this one would be faster. So this is how the scalar computation looks like. Simple program which we all have been doing for very long time, and this was fine for us. So this was not a problem for anyone unless these Java people came and told us that, hey, this is slow. You can use this big chunk of code to do the same thing. And this, as they say, this one is faster because this one gets executed in a single instruction. Having said that, there are caveats because when I ran this program for the size of the array being 1,000, I found this one to be faster compared to this one. So I think yes, they have a performance benchmarking mentioned in their website. So I think it is good for us to, it would be good for you to go through the performance benchmarking in the website and then decide whether you want to use this big chunk of code or whether you can use this. In most of the cases, you will be better off doing this because this is easy to read. You would not make mistakes. There are, in a particular team, in any team or any project you work upon, at least 4 or 5 developers are there, and anyone can understand this code. And if you write this code, then first of all, in your pull request, people will ask what it is, and then you will just keep on you will end up explaining everyone, and the subsequent developer will scrap off this code and write this code. So you must have a very unique use case, or you absolutely need it, then you can try this. And of course, by measuring the performance benchmark and seeing that whether you actually need it or not. But for me, in the coming future, I live with this particular solution. So this is how we cover all the features of Java 19. You can see that these features are being categorized into 3 verticals, and it was something which I wanted to explore because Java is quite popular, and I have personally also worked on Java for quite a few years. So it is always important for us to understand where the language is going forward and in which direction it is going. So once you understand the language and you understand the power of the language, so you can decide that what exactly you should do, or what exactly you should choose. So in a company in which the project is going to be there for, let's say, next 5 years or 10 years, so it's very important to make a right choice of the language or the framework. What are the power of the language, what support it is having, and what are the future plans of the language. So apart from a lot of things like availability of developers, these factors definitely make sense. So I explored this feature and wanted to share with all of you. I have a YouTube channel with the name of Anwar Srivastav, and this profile pic, you can go and subscribe to the channel if you like it, so that I would love to post videos on an average every week on the topics specific to backend engineering, and the topics would mostly be around whatever I'm curious about. So this week I was mostly curious about what are the features on Java. So talked about this. Possibly next week I am working upon database related stuff. So would love to share the information around various things coming in the software development. Do check out the channel. There are quite interesting videos. Till then, thank you. Bye.